Assalamu alaikum student. Let's start today our lecture number 13 on the still we are on the application layer, chapter number 2. We stopped in the last lecture on web caching, and we looked at why we have a proxy server in our LAN for caching the web page into it and serving the requests of the user on the LAN locally from the web cache, instead of sending the request to the origin server again and fetching the web page or bringing the web page from the origin server again. The job of the proxy server or the cache server is to serve the request locally on the LAN so that the bandwidth can be saved, okay, and the response to the client request will be quicker. Okay. So cache act as both client and server, okay, because when it is serving the client request, it is acting as a server, but when it is fetching a page from the origin server, it is acting as a client, because it has to update the copy of the web page in its cache, and for that reason the proxy server, the cache, will fetch the copy of the website from the web server. In that case, the cache is acting as a client to that web server, and when it is serving to the client in the LAN, it is acting as a proxy server. Okay, so cache act as both client and server. Typically cache is installed by ISP. It is installed on the ISP end, but universities, companies and residential ISPs, they can also have cache in their own local area network in order to meet these objectives. Okay, why it is required on the web to cache the pages? It reduces response time for client requests. For example, when a client send a request, okay, to the internet, so instead of sending the request directly to the origin server on the web, first the request is sent to the proxy server on the LAN, or you could say it also a cache server. Cache or proxy is the same, both are meeting the same purpose, fulfilling the same purpose. It will reduce the response time for the client request by serving the client request locally instead of sending it to the origin server on the internet. It reduces the traffic on the institution's access link. Access link is that link which is connected to your service provider, okay, and definitely it will consume the bandwidth. Okay, internet dense with caches enable poor content providers to effectively deliver the content. Okay, so it will definitely internet we have a lot of cache servers. Every local area network is having one caches installed in their network so that they can serve their client requests more in a more better way and more quickly from the local cache, instead of sending the request on the origin server to the origin server on the access link and overburdening the access link. Okay, so it gives basically both the advantages, a quick response to the client request and saving your access link bandwidth. Okay, now this is an example for the caching in terms of looking into the delay. Okay, look here, this is a specific institution network. Here this is an institution network. Okay, this institution network is having 100 Mbps LAN bandwidth. Okay, and this is the router of this institution network. These are the client machines. Okay, and this institution network is connected to its service provider, and the link access link's capacity is 15 Mbps. This is the router of the service provider. Okay, and this is the internet, public internet, on which we have so many definitely servers, and our client will be going to send definitely a request to one of these origin server. So assumption is this, on this topology, on this setup, that average object size is 100,000 bits, okay, which needs to be requested from the origin server. Okay, average request rate from the institution's browsers to the origin servers is equal to 15 requests per second. that from the institution network the clients are going to send 15 requests in 1 second from this network to the internet. So this, if 15 Mbps is the bandwidth of the access link and 15 requests are being sent per second, we have to look the utilization of this link, that how much the link will be utilized. Okay, delay from the institution router, that the institution router from here to any origin server request, when it will, the request of the client will get out of the institution router and it will go over the any of these origin servers, and it will be returned back the response in terms of a response to the router. The delay from the institution router to any of the origin server and back to the router is 2 seconds. So this is the internet delay, because definitely it will go through multiple hops and it will reach to the origin server, and the reply will be sent from origin server to the ISP router and from ISP router to our institution's router. Okay, so this is the internet delay, which is 2 seconds. What are the consequences in this scenario? The utilization on the LAN is 15%. Look here, 100 Mbps is the local LAN bandwidth, and 15 requests per second are going to be sent from the client browsers. So 15% of this bandwidth is utilized. Okay, utilization on the access link, 15 requests per second and 15 Mbps is the bandwidth. So 100% utilization of the access link is 100% utilized. Okay, now the total delay, if we will calculate here, it will be the sum of the internet delay, which is in our case 2 seconds. Okay, plus the access delay, and access delay, you know that it will be in minutes, because the whole access link capacity is fully utilized, 100% utilized, so it will be in minutes. Plus in millisecond is the LAN delay, because it is only 15% utilized. We have more capacity and less number of requests, so 100 Mbps is a good capacity on the LAN. Okay, so this delay, the LAN delay, will be in milliseconds. So once you total it, it will give you the total delay in order to fulfill these 15 requests per second from the origin server over the internet. Why don't we have another solution in which we can better utilize this access link, and we can serve the request locally instead of sending the request to the origin servers over the internet? Okay, this is we have to introduce something here. For example, the solution is this, that one of the solution is the caching. The other solution is you can also increase the capacity of the access link or the bandwidth of the access link. Instead of 15 Mbps, you can make it 100 Mbps. Now what will happen? Possible solution. This is one of the possible solution, that increase the bandwidth of the access link, for example, say to 100 Mbps instead of 15 Mbps. Okay. Now what will be the consequences in this case? Utilization on the LAN is still 15%, because we have not changed anything here in our local LAN. The utilization on the access link is reduced from 100% to 15%. Same like this, 100 and 100, 15%, 15%. Okay, 15%. In this case, the total delay, if you calculate it, the total delay is, do remember it, it is the internet delay plus the access delay plus the LAN delay. Internet delay is here, access delay is here, and the LAN delay is here, because these are three, you could say, three areas are there, or the three networks are there where it is, it could cause delay. One on the LAN, okay, one on the access link, and one over the internet. Internet, you take it as a whole internet delay, because internet, there are so many hops on the internet, and you don't know that the packet will pass through how many hops and it will be returned to you, and what will be the condition of congestion over each router on the internet, because this delivery will not be a direct delivery, it will be indirect delivery, it will be from node to node, okay, or hop to hop, and then it will be ultimately reaching to the destination, and the reply will come back from destination to the source host. Clear? So now in this case the total delay will be the internet delay plus the access delay plus the LAN delay. So internet delay is still 2 seconds because we have not changed anything here or here. We have only increased the capacity of the bandwidth of the access link. Clear? So this delay 2 seconds and this delay in millisecond is not going to be changed. 2 seconds and millisecond. This is not going to be changed in this scenario. Only the delay here in minutes due to less bandwidth and due to the increase in the bandwidth will change from minutes to milliseconds. Definitely in this case the delay will be less or more? Less as compared to the previous scenario. Whatever is the answer, it will be less as compared to this scenario. If the access link is having 15 Mbps bandwidth and here by increasing it, this is one of the possible solution. If you increase the bandwidth to 100 Mbps, it would be much better as compared to having 15 Mbps bandwidth on the access link. Clear? So in this case you will face a less total delay as compared to the previous scenario, but what is the cost you have to pay here to get 100 Mbps from your service provider? Will it be a cheap solution or costly? It will be very costly solution. You are using in your home 1 MB, 2 MB, 4 MB, maximum 20 MB, maximum Envision, maximum the triple play services which you are getting, telephone, data, voice, data and video, Envision video, maximum for 20 MB or maximum you can go to 40 MB and you have to pay how much? You know, if you move from 4 MB 150 Riyal to 40 MB 800 Riyal. Have you seen the difference? And if you go to 100 Mbps, how much you have to pay? So this is not a cheap solution. It is a very costly upgrade solution. So we have to look into another solution. The second solution over here is the introducing the cache here. Bring it back to 15 Mbps instead of 100 because it is very costly solution. We can't afford it. So we will keep it 15 Mbps on the access link. Okay. And we will introduce in our LAN a server which is the proxy server, the cache. Okay. And now, yes, please.
The access link, if we increase it by 200%, there will be no delay?
Yeah, it will be very definitely internet delay will be there. By increasing the capacity of the access link to 200 Mbps, definitely this delay will be reduced. But this delay is over there. It is beyond your control. Only this and this is in your control. You can play with this too. In solution 1, we have increased the bandwidth here. In solution 2, we are going to have a solution in our own local LAN because we don't want to pay for the access link a huge amount. Rather than paying a big amount of money for the access link bandwidth increase, what we are going to do, we are going to introduce a local proxy server in our LAN in order to serve the user's request, client request quickly. And we can save our access link bandwidth as well. No need to pay it, no need to increase it, no need to pay more for it. Clear? So look here now, we introduced here a cache server. This is a possible solution. Another possible solution that we have to install a cache in our local area network. Okay, and this cache hit rate is suppose 0.4. Okay, now here the consequences are that 40% requests will be satisfied almost immediately from the local cache. Whenever a client wants to browse a web page, first it will be sent to the cache and it will be checked in the cache. If the web page is available, it will be served from here. The request will not go to the origin server over the internet and our access bandwidth will not be used in that case. So 40% of the request will be satisfied almost immediately within the local LAN from the cache server. Rest of the 60% requests will be satisfied by the origin server. In this case, we have to send 60% of the requests still to the internet, and those requests will definitely utilize this link, and their data will be brought back from the origin servers and their requests will be fulfilled. Now the utilization of the access link in this case is reduced to 60, because here when 50 requests are being sent per second, its utilization was 100%. Now if you are serving 40% request locally, so it will be reduced from 100 to 60, because 40% are satisfied internally from the cache on the LAN, and 60% are still going on the internet. So its utilization is reduced from 100 to 60%. 40% is saved, served internally from the cache. Clear? Is this concept clear to you boys, please?
Yes.
Everybody? Okay, good. So utilization of the access link is reduced to 60%, resulting in negligible delay, say 10 millisecond. Negligible delay, 10 millisecond is reduced in this case. So total average delay in this case will be internet delay plus access delay plus LAN delay. So internet delay is, we have studied it 2 into 60%. Still 60% requests are still going to be sent over the internet, plus the we call it LAN delay, okay, and access delay, internet delay 2 plus the access delay on the access link is reduced to this. Internet delay is still there, plus the LAN delay. So it will be approximately, because this is the LAN delay, okay, so it will be 0.4 into, it is already millisecond. Definitely, because now the traffic on the LAN will be increased for the 40% request. 40% mean 0.4 into 40% of this delay, which is already there, which was already there. 40% of the delay is increased on the LAN. 60% delay is, it is reduced from 100 to 60 on the internet, on the access link, sorry, and internet delay is still there to second. Clear? So this will be less than 1.4 second. The answer is less than 1.4 second. And in that case, we were facing how much? 2 seconds. More than 2 seconds. Look here. It was equal to 2 seconds plus this and this. It was more than 2 seconds, and in this case, it could be in minutes. In minutes, in seconds, and now it is less than 1.4. Definitely more than 2 seconds by increasing this. This is a good solution, but costly solution. Better than this, we can have another solution better than this solution by introducing a local cache. So in this case, the delay will be less than 1.4 seconds. So which solution is better? This one, which is more costly, and delay is not reduced up to a significant level as compared to this one, in which the delay is reduced to a significant level, and the solution is also not very costly as compared to this solution. But definitely you can say that here we have to invest here on the cache server. You have to buy a machine, a new machine, a server computer, and you have to configure it as a cache server. So it can be done. Squid is the Linux cache, or we have the Microsoft cache server is a server. We can use it, okay, and definitely we need a software and a hardware to configure it. So this is one-time investment, but it will serve in the future for long period. It is a one-time investment but long investment, okay, and it will give you long-term benefits. So this is the more better solution as compared to the previous solution. Okay, yes.
Where is the access delay?
Access delay is here on the access link. LAN delay is here, and internet delay is here. These are the three type of delays we have written in the equation of total delay. Internet delay, the first delay is the internet delay. This will be faced here over the internet. Okay, the second delay is the access delay, which is here, and third delay is the LAN delay, which is here in the LAN. Because now the traffic on the LAN will be increased 40%. So whatever delay you were facing on the LAN, just multiply it with 40% or 0.4. Whatever delay you were facing on the access link, okay, that is reduced to 60% now, from 100 to 60. Okay, and because you know that this was from this, we looked here that internet delay is still 2 seconds, which we are facing over there. Yeah, it is here. Conditional get, this is that the cache, it will conditionally send a get request on the internet to fetch a web page, to bring a web page, or to access a web page from the web server if it is not available in the cache of the proxy server. Clear? When I say cache or proxy, it is the same words. Okay. Now look here, conditional get mean that if the cache will first check, the request of the clients will go to the cache will first check. If the cache can satisfy the request locally from its cache, it will not send the request to the origin server. It means the page is available in the cache. It will be served locally. So access delay will be saved in that case. Okay. But in case of if the request cannot be fulfilled from the cache, it has to be sent to the over to the internet, public internet. In that case, definitely it will fetch a new copy of the web page from the origin server. It will keep one copy in the cache of the proxy server and one will be given to the client. So goal is, don't send the object request if the cache has an up-to-date copy in the cached version. Okay. Now cache request will come to the cache, HTTP request message, it will come to the cache if it is modified since the date. You know that we have a date modified. Okay. If it is already there and it is not modified since that date, object not modified, okay, what the cache will do, it will send a HTTP response, HTTP 1.0 304 not modified. If it is not modified, it will return the page, cache specified date of cached copy in HTTP request if modified since this date or not. If not modified, it will be served locally. But server response contains no object if cache copy is up to date. HTTP 1.0 304 not modified. So the cache will check with the origin server whether the copy of the object which I am having is latest or modified. If the cache will get a response from the server that object not modified, what it will do, it will serve the client request locally. So in this case, the cache has not cache will not need to bring the whole object. It will just send code to check whether the object is modified or not. If it return status code, okay, with the status text code 304 not modified, it means the copy which I am having in my cache is the latest. So I can serve this to the user. But if it is changed, HTTP request message if modified since object modified, then the response will come back HTTP 1.0 200 OK and data. 200 OK we looked in our first example of HTTP protocol. 200 OK means the request is received and it is going to send you the web page. So now it is modified. The object on the server has been modified. The server will send a latest copy of the web page or the object to the cache web server. So cache will update its copy in the cache and serve the client request. Now the cache, like this, the cache will keep on updating the web pages which it is having in its cache. It is not going to serve you with the old pages, the expired pages, the old pages, not the latest pages. Along with the serving your request locally, it is also updating its cache by communicating with the origin web servers, just by exchanging the code. If it is modified, okay, it will update the copy. If it is not modified, no use to put extra burden on the access link. So the code will not take too much bandwidth and overburden the access link, rather as compared to the bringing the whole web page every time from the origin server. Is this concept clear, guys, to you?
Yes.
Good, very good.
Upload date. What's the number of days that there will be?
Whenever the page is modified, the date will be updated on the origin server. And whenever the page is accessed, that date is sent along with the page, that when this page was last modified. So you can come to know that this page, when this page is updated, okay, and it will compare that date by sending the access code. Clear? FTP, another application layer protocol is FTP, file transfer protocol. Now FTP is a file transfer protocol on the application layer, which is mostly used on the web to upload the files on the file servers or to download the files from the file servers. Okay, that is why this protocol is called FTP, file transfer protocol, to from the remote host, and that remote host is called the file server. It will have a remote file system here. It will store the files here, okay, uploaded by the users, and from here it will download the files. And it is a client server model, because the client computer, the user computer is acting as a client, and the server on which the files are uploaded or to or downloaded from is called a file server. So it is basically having a client server model. Client basically side will initiate the transfer request, either to upload a file or from the server to download a file. Okay, and that will be a remote server, and server will be a remote host. In this scenario, this is the server, this is the client. You can find more detail about FTP from for the FTP from RFC 959. This is the number. If you write RFC 959 on Google, it will give you the whole details, complete detail, latest update of the FTP. FTP server uses port number 20 and 21. Okay, so let's have a complete look into the FTP protocol working. Control, for the control connection, the port used by the FTP is 21, and for the data connection, the port used by FTP is 20. That is why I call it, it uses two port, 20 and 21. 21 for the control, 20 for the data. Yeah. The one which is coming before 20, it is for the data, and which comes after, it is to controlling the data. Clear? 21. Now look here how the FTP will be working between the FTP client and FTP server. This is FTP client, this is FTP server. There will be two connections, one for the control, one for the data transfer. The control connection will be TCP control connection will be on port number 21, and TCP data connection will be on port number 20. Can you tell me FTP is utilizing the service of which protocol on the transport layer? UDP or TCP? TCP. Why?
Because up to that, it's using the websites. Because we can't lose.
We cannot afford the loss of the data in the file. We do need reliability in either uploading the file or downloading the file too from the web server. It can't be possible that half of the file is loaded and half of the file has gone, lost somewhere on the way. We do need a reliable delivery of our files to from the file server. For this reliable delivery, we do need the services of TCP protocol. We do need the services of TCP protocol on the transport layer. And transport layer, TCP protocol, you know that it is reliable protocol. Okay? And this is a connection oriented protocol. It means before the FTP data begins, it does need a connection setup. Like HTTP, it also uses TCP. So before the HTTP request is sent, the connection will be set up. Same like here, before the FTP request is sent, a TCP connection has to be set up. Before the transfer of the file begins, a TCP connection needs to be set up. Clear, guys? Okay, let's start. FTP client contacts the FTP server at port 21. Why? To initiate a TCP control connection on port 21. TCP is the transport layer protocol, and it will establish a connection between the FTP client and FTP server on port number 21. Clear? Once the connection is established, the client is authorized over the control connection. Once the connection is established, now the client browses the remote directory. For this client, there will be a directory. You have seen there is a database here, and every client will be assigned some place on the FTP server. Okay, and there will be directories on that hard disk in which the FTP clients will upload their files. Clear? So client browses the remote directory on the FTP server by sending the commands over the control connection. Now all the control commands will be sent over the control connection between the FTP client and FTP server. Yet we have not started the transfer of the file from either side. Clear? Yet we are connecting, we have got a connection to the FTP server, and we are looking into our directory where we have already kept our files. Okay. When the server receives the file transfer command from the client, the server opens a second TCP connection, this one on port 20, for the transfer of the file to the client.
So they are separated.
They are both separate connections. TCP connection on port 21 is to send and receive the control messages in between the FTP client and server. Clear? And on port 20, TCP will have another connection for the transfer of the data in between the FTP client and server. Okay, so client data is kept separate from the control messages. Clear? So when the server receives file transfer command or request, server will open another TCP connection for the data for the file to the client, and that connection will be on port number 20. Clear?
But why separated TCP?
Because the messages exchanged to control the transfer of the data is kept separate from the message from the data which is sent over a connection, separate connection. Okay, because the file transfer, the data transfer should not be disturbed by the controlling messages, because if the file is very big, it will be divided into small chunks or segments, and every segment does need a reliable delivery. Whether if a file is, for example, divided into 50 segments, a big file, so for every segment you do need an acknowledgement from the server. First segment, received or not received. Second segment, third segment, fourth segment is lost on the way. The server will send a control message on the connection 21, port 21, that the fourth segment is lost. It has to retransmit the fourth segment. Otherwise, the data from the file will be missing. So in order to reliably deliver a complete file to the file server or retrieve a file from the file server, it does need a reliable delivery, and control messages are being exchanged in between the file transfer. So that is why it is kept separate. Both the things are kept separate to reliably deliver the data to the file server. So after transferring one file, server will close the connection, data connection, and if you do need another transfer, you have to open another data connection. Okay. So server opens another TCP data connection to transfer another file. Control connection is out of band, mean it is separate than the data connection. FTP server maintains state. Okay. For what? For the current directory, that what is happening in current directory in which the user is accessing, uploading a file, or from that particular directory he is downloading a file, because on the FTP server many users will be uploading or downloading their files. So for every user there will be a separate directory. Clear? So earlier authentication, when the authentication was done, for that authentication on port 21, there it will maintain a state on the FTP server, and what activities are being taken place in the current directory, for that it will maintain a state. So it is a state, not a stateless, it is a stateful protocol. Okay, it will maintain the states. FTP commands and response codes, for example sample commands, send an ASCII text over the control channel, and it will send username and password from the client computer to the FTP server computer. List mean it will, the server will, list mean it is asking to return a list of the file in the current directory, that kindly send me a list of the files in my directory. Okay. Retrieve mean the file name retrieves get file. I will retr mean I want to retrieve this particular file from my directory. This is the command to retrieve a file, to get a file. Stor file name, a store file name, a store, or puts so the file onto the remote host. So basically FTP works with two basic commands. One is the get, to get a list of the files available in my directory on the FTP server, and puts mean to send a file, to store a file on that particular directory on the FTP server. Clear? And list is to look into the directory, that how many files are there and what are their names in my directory. But prior to that, you have to send your username and password to be connected with that file server. It is not open access. Everybody cannot go and check in the directories that what files are kept there, because every directory belongs to a particular user, and the user has to be authenticated before he is given the access to that directory. If you are a valid user and you have a FTP username and password which is stored in the database of the FTP server, then only you will be given access to the FTP server, and you will be given access to your directory only, in which you have kept your files, from where you can download or upload the files.
What about media file or these websites for getting the files?
And this is on FTP server, basically you upload the files.
Yeah, but when you download, you don't need the username and password.
Once you have been connected with the server, so unless until the transfer gets complete, your connection will be open. Once the connection file has been downloaded, then the connection will be closed. Okay. So on the sample return codes, these are the sample commands from the client side which are being sent to the server, and these are the sample return codes which will be returned by the server. Status code and phrase as in HTTP, same like as we have seen some of the status codes and their phrases in HTTP server. Example 331 username OK. It will return you a code 331. It's mean the username which the client has sent, it is OK. Password required. Now you have to give the password. Once you give the password, and if it is verified 125, data connection already open. This code is written that the data connection is open already. You can transfer the file, start transferring the file. 4 to 5 can't open data connection. It cannot open data connection. There is some error, might be the server is down or the password is not correct. Okay. 452 error writing file. There is some error in writing the file. These are the sample codes. Next topic is electronic mail, which will use the SMTP POP3 and IMAP protocol in order to transfer the email, send and receive the emails. Okay, this is another application layer protocol, file mail transfer, electronic mail transfer, or you can call SMTP POP3 or IMAP protocol. Okay, electronic mail example. I'm going to stop here this topic, and we will start in the next lecture this topic, inshallah. Thank you, guys.